Hello students, let's look at this question here. Before we even work it out or handle this question, you are already faced by some strange looking notations here. But not to worry, it's also a good way to get yourself familiar with some different notations in dealing with functions. So this expression here means exactly the same actually as writing fx equals x cubed minus 2. So this is just a function f with the formula x cubed minus 2. And here you are asked to verify certain things. And don't forget this little circle here means just a composition of functions or composite functions. So in this case you are asked, will it be true, or is it true that when I do a composition of functions, and if I actually first work out the inverse function f, so by the formula of inverse of function f, who is the partner that I'm looking for, and then if I continue with function f, will I end up with x again or not? And the other way around, if I first do function f and apply it to x, and then afterwards I continue with the inverse of function f, will I end up with x again or not? Basically, when you think about it, we talked about this already as well. If we illustrate it with a mapping diagram, if I have a value x here somewhere, and by function f, by the rule of function f, x has a certain partner here or image, then when I apply or when I work out the inverse of function f, which just goes the other way around, it makes sense that I will end up with the same guy again. So let's look at it algebraically and see whether it actually makes sense as well, and whether it is really true that you end up with x itself. So first of all, before we can do anything, we will need the formula of inverse of function f, and you are actually very familiar with this already. So I'm just going to work it out very quickly. I first write down y is equal to x cubed minus 2, which is the equation or formula of function f. And then of course you will remember the first step to find the inverse of function f is just swapping the position of x and y. So in this case I will have x equals y cubed minus 2. So adding to both sides, I will have y cubed equals x plus 2. And the last step, taking cube root both sides, I will end up with y equals, I'll just write it here, cube root of x plus 2. So the formula for the inverse of function f is actually cube root of x plus 2. Okay, so now knowing the two formulas of these functions, we are going to check. Okay, in question A, so remember this notation just means composition of function, and of course the one nearer to x is to be done first. So this is the inside function that you need to do first. So okay, in this case, since there is no particular value or number that you need to substitute, then we just have to check, okay, what is the formula of f inverse of x, and we have it actually right here. So the only thing I do now is just to replace f inverse x by its rule. So this will be the partner of x if you find its image using f inverse formula. So right there. And the only thing I have to do next is to use this and replace this, substitute this into the x position of function f. So in that case, then I will have here, I will replace or substitute this x by cube root of x plus 2. So then substituting that to the formula of function f, I should have something like this. So cubed and then minus 2. So now easily you see that cube root and cubed are just opposite operations, so they cancel out and you will end up with just x plus 2 from this bracket operation, and you still have this subtraction by 2 as well. So in the end, x plus 2 minus 2, you will end up with x. So then it is verified on question A. Let's use a different color now, and we would like to verify question B as well. What if I do it the other way around? If I first apply or use or work out function f, so that will be my inside function. You see here f is actually nearer to x, so then that is to be done first. That will be my inside function. So when I work it out, then I'll just have to replace this by the formula of function f, x cubed minus 2. Now I will follow that by substituting x cubed minus 2 into the formula of f inverse, which is in this case cube root of x plus 2. So then I will just replace or substitute this x cubed minus 2 into the position of x in this formula. There. So then I will have cube root of, so I'm replacing the x by x cubed minus 2, and then I still have in the formula plus 2 afterwards. So this is what we end up with. And from there I see that opening the bracket, I will just have very simple thing, x cubed minus 2 plus 2, which means in the end minus 2 plus 2 is gone, and you will just have cube root of x cubed. Now guess what? Cube root of x cubed. Again, they're cancelling out each other and you will end up with x itself. So now we have verified that apparently when you do composition between function f and its inverse, then you will always end up with x. So you will just basically go back to the original number you begin with.